Hello everyone, my name is Ashwarya. In the course of Design and Analysis of Algorithm, today we are going to discuss what are the different type of analysis. So if you are writing any algorithm, you can analyze that algorithm or you can find the time complexity of that particular algorithm in two different methods. First of all is you can do a posteriori analysis. The second is you can do a prior analysis. What are the major differences between two analysis? I will tell you. So if you talk about a post analysis, this is the analysis that is giving you the relative analysis. It's a kind of relative analysis and it will give you the exact answer. Means when you are writing any algorithm, you will write the code for that particular problem and then you will execute it on some kind of compiler or system. So this analysis is being done once you have written the code and you have compiled that code. So a post analysis will be done after the execution of any program, after the execution of that algorithm. But in the case of a prior analysis, it is done once you are writing the algorithm. You have to check how many times that particular algorithm steps are working, how many times they are executing, and it will also give you the approximate answer. It is an absolute analysis. As we are talking about that, a post analysis is totally when you are writing a code and executing it on system. So it will be it will be it will be dependent on the language of your compiler. It will be dependent on your hardware that you are using. Similarly, a prior analysis you are doing after writing the algorithm, so it is totally independent of the language of the compiler as well as the type of hardware you are using for execution. So as a post analysis is after analysis, after executing the program analysis, so it does not use any kind of notations to identify the time complexity of the algorithm. But in the case of a prior analysis, as it is giving you approximate answer, so you need to represent, you need to have some kind of notations that will help you to represent that how much time the algorithm will take to complete its execution. In a post analysis, as it is totally dependent on the totally dependent on the type of hardware, so it is differ from system to system, but not in the case of a prior analysis. And it is also giving credit to the compiler as well as to the hardware, but a prior analysis is totally giving credit to how the algorithm is being written. So these are two different these are two different analysis that is being carried to analyze any algorithm time complexity, whether it's a exact answer you are getting, or whether how you can get the approximate answer of any algorithm time complexity. So before heading to how to find the time complexity, I would like to tell one more topic, is that is brute force. This is the straightforward approach that will help you to solve any kind of problem and it will definitely give you answer. But irrespective of what the time that algorithm will take, it will definitely give you answer. So in some cases brute force is giving you the easiest approach, and but not in the every case. In some cases it will give you the solution in lesser time, but it cannot be applied on every kind of problem where the size instance, where the number of input is bigger. The brute force will work as a exponential time complexity algorithms. So not in every cases, but in some cases brute force algorithm is also applicable. Now as to find what is the time complexity of any algorithm, we will be doing the time complexity analysis in the case of a prior one, because we are writing the algorithm and we will try to figure out what will be the time complexity for that particular algorithm. So before knowing how to analyze any algorithm, first of all I would like to tell you the cost of basic operations that you can have in your code. So first of all, basic operation, it can have the addition one, multiplication one, division one, floating point addition, floating point multiplication, and many. So these all basic operations will take constant time. You can easily see that it's 2.1, 2.4, 5.4, 4.6, and so on. So these are some constant time that is being taken by these basic operations. So all you can write it as these are constant time algorithms. These are constant time operations, that is that can be there in your program. So if there is any program that is having any operation which is basic operation, you need to just write that complexity will be equals to constant time. You can have more basic operations that will also take the constant time. If you're declaring any variable, if you're assigning some values to any variable, if you're comparing two variables, and so on, these will also take constant time. So these times will also be C, which is constant. So let's discuss with the help of an example that whenever you are having any program, whenever you are having any code, program, algorithm, and you need to do the Apriori analysis, what you can do is you just have to check what are the instructions that are included in the algorithm and how many times that particular instruction is executing. Means if you are writing variable declaration, how many times the variable declaration is being done. If you are doing assignment statements, how many times that statement is happening, and what are other things. So as you can see in this particular code, there is a int count is equals to 0. Count is a variable which is declared as integer and its value is equals to 0. Similarly, I is also an integer and it is also equals to 0. It's also assigned to 0. And you are executing one loop which is I is equals to 0 to I less than n and incrementing every time the value of I. So the operations which is happening in this particular program, which is sum, that is variable declaration, assignment statements, less than compare, equals to compare, access, array access, and increments. Only these 6 operations are being performed in this particular sum program. So what is the frequency respective to this is how frequency is also written in right side. So you can see that total number of execution that is happening to this particular program is dependent on the loop. So if in the case you are having basic operations, you can directly write C, constant is the time complexity. But if in the case you have loops, if you have loops, you have to check that how many times that particular loop is executing. So for loops case, you have to check how many times, but for the case of basic operations, the time complexity will be constant, which is, you can write it as order of magnitude constants. So this is the way you can write. So in this case, the sum program, you can see that this will execute n times roughly. I will explain you later in detail, but roughly you can just see that it will execute n times because there is a loop which is executing 0 to n, which is n times. And there is one condition also, which is ai is equals to 0, which is a equal to compare condition. So this is how you can see if basic operations are there, you can have the time complexity equals to constant. But if you have any loops, you have to check whether the loop is executing how many times. The loop is executing how many times. You have to check loop is executing how many times. So let's take some examples for this. Okay, so I will be doing the Apriori analysis as I told you earlier. So I will write whatever the statement is executing, whatever the number of time that statement is executing in that program, I will write its order of magnitude. It is written like this: order of magnitude, whatever the time it is taking. So I will write like this. It will be written as order of magnitude, whatever the time that algorithm is taking. Okay, so let's see in example this one. Let's see in this. What is written is, main function you have written one statement, that is x is equals to y plus 1. You can easily see that x is equals to y plus 1, where it's a basic operation which is plus operator, and then y plus 1 value is assigned to your variable x. Means two basic operation is happening. One is your addition, integer addition, and second one is your assignment. So both are basic operations. Simply you can write the time that is taken by this statement will be constant time, or you can write it like this also, order of magnitude 1. Both are same. See, so what you can do is, this statement, the program which is this one, is having one statement which is x is equals to y plus 1. Y plus 1 is simple addition, which is a basic operation, and then you are assigning the total value to x, which is also basic operations. So two basic operations is taking time constant, and you can write it as constant time, or you can write order of magnitude 1. Both are same. So both are correct. Next, try to this. These are two statements. One is x is equals to y plus 1, and second one is x is equals to y plus 2. Now see what is going to happen. As you can see, this instruction is same as previous one. So it will take order of magnitude 1 time, or I can even write it as 1, for example. Now see this one. This is a for loop. This is a for loop. I told you, when you are having basic operation, just write directly. Basic operation will take constant times, but in the case of loops, you have to check how many times that loop is executing. So as you can see, the statement 2 is written inside the loop. The 2 statement is written inside the loop, so you have to check whether it is executing how many times, whether it's executing n times, or how many times you have to check. So let's see, I is equals to 1. For I is equals to 1, it is executing. For I is equals to 2, for I is equals to c, you can see it will execute till I less than equals to n. Means how many times it is executing? Let's see, n value is 4 in this case. Let's see, n value is 4 in this case. So for I is equals to 1, it will execute. 1 is less than equals to 4, condition is true. For 2 is, it will execute, condition is true. For 3 it will execute, condition is true. For 4 it will execute, condition is true. So you can say it will execute 4 times, means it will execute how many times? N times. So statement 2 will execute n times. So for basic operations, the time complexity will be constant. For loop, you have to check how many times that loop is executing. So in this case, it is executing from 1 to n, means 1, 2, 3, 4, 5, 6 till n, means n times. This statement, this updation of y value will be happening n times, along with some constants also, because here also you are doing some addition, you are doing some assignment, but this will happen how many times? For I is equals to 1, for I is equals to 2, for I is equals to 3 till n. So let's see what is the total time that is needed by this algorithm. Will be 1 plus n. You can write it as order of magnitude, and you can neglect 1 over here because 1 is far lesser than n value. So n is the total time that is taken by this algorithm, right? So this is how you can find the simple time complexities of the algorithm that is having basic operations as well as some simple loops. Now let's check for some other programs also. Let's see, I will write one program which is, let's say, while loop you are having, and it is something like while n is greater than equals to 1. Let's say while n is greater than equals to 1. So what is happening is n is getting decremented by 1 this time. N is getting decremented by 1. So let's say this is a program. This is a simple program. I have not done any rocket science in this. It is a simple program. So let's see how many times this will execute. Let's see, n is equals to 4. You have some n is equals to 4. You can just see while, let's see, 4 is greater than equals to 1, condition is true. 4 is greater than equals to 1, condition is true. As its condition is true, definitely what will going to happen is the value of n will update. The value of n will update to n is equals to n minus 1. Means n will become 4 minus 1 is equals to 3. The value of n will become, let's say, 3. Now again you will move to your loop. It will be 3 is greater than equals to 1. Condition is true again. N will become n is equals to 3 minus 1, which is equals to, let's say, 2. So n is updated to 2. Again you will execute the while loop. 2 is greater than equals to 1. Condition is again true. You will make it n is equals to 2 minus 1, which is equals to 1. Now n value will become 1. Now see again, while 1 is greater than equals to 1, condition is again true. What will happen? N is equals to, what will happen? N is equals to 1 minus, or you can even say it as 1 minus 1, which is equals to 0. Now let's move to while loop again. 0 is greater than equals to 1, condition is false. It will stop. It will stop executing. How many times it is executing? 1, 2, 3, 4. It is executing how many times? It is executing 4 times. It is executing 4 times. Let's see. Let's write it like this. It is executing 4 times. Just remember this now. Now let's try to execute this for some other value. Let's see. Execute it for some other value. कौन है ये कुत्ता? इसमें आ गया होगा. फिर मैं एग्जीक्यूटिंग कर देता हूँ. रिज्यूम किससे होगा? ये रिज्यूम तो पता ही नहीं मुझे किससे होगा. पॉज के लिए डी थोड़ी ना दबाया था, क्या दबा? Let's try it for some other value. Let's say I will try it for n is equals to, let's say I will try it for n is equals to let's say it is executing 4 times. Okay, fine. Let's say we have some other statement also, as in n is equals to n minus 2. Let's say I have this also. Let's say I have this also. This is another one. This is the another one. I have this. First of all, I was having this one. Let's mark this. Another I am having this one. So how many times it will execute when n is equals to n minus 2 is the statement. Let's see. While 4 is greater than equals to, and n value is same, 4 is greater than equals to 1, condition is true. What will happen is n will become n minus 2, means 4 minus 2. It will become 2. A condition is true. Now check for another value. Let's see. 2 is greater than equals to 1. Condition is again true. So you will do it. 2 minus 2 is equals to 0. Now see, while 0 is greater than equals to 1, condition will become false. So you can see for n is equals to n minus 1, when n is equals to 4, it is executing 4 times. When n is equals to n minus 2, it is executing how many times, student? It is executing 2 times. 2 times. The statement is executing, loop is executing 2 times. So let's see for n is equals to n minus 3. One more statement, n is equals to n minus 3. For third one, I'll take. Let's see, while, see, while 4 is greater than equals to, 4 is greater than equals to what? 1, condition is true. It will become, what it will become? It will become 3, it will become what? 4 minus 3 is equals to 1. Now, let's check it for 1 is greater than 1, condition is again true. It will execute for, let's say, 1 is 1 minus 3, which is anything minus 2, and condition will become false. So in this case, it is executing, let's say, 1 time. So you can see, same while loop, if having statement n is equals to n minus 1, it is executing 4 times. If it is having statement n minus 2, 2 times, n minus 3, it is executing 1 time. So what conclusion we can come out of is, let's see, for a statement having n is equals to n minus 1, it is executing how many times? 4 times. And it is specifically for n is equals to 4. Value of n is equals to 4. 4 times. Okay, see one thing. Can I write it like this? 4 times means, can I write it as 4 upon 1? It is 4, it is fine. I can even write it as n upon 1. Is it fine also? Fine. For n is equals to n minus 2, let's see. I will be writing, it is executing 2 times, as I told you. And I can write it as 4 upon 2, which is 2 times. 4 upon 2 is 2. And can I write it as n upon 2, 4 upon 2? Fine. I am relating this value. Just see, I am relating this value. Just see, I am relating this value. Now, n is equals to n minus 3. You can write it as 1 time. And even you can say it as 4 upon 3, which is something 1 point. So you can write it as 1 n upon 3. So whatever the statements are coming, n is equals to n minus k. The time that is being taken by that statement will be order of magnitude, students, n upon k. You can see n upon 1, n upon 2, n upon 3, n upon 4, and so on. So whatever value of k will be 1, 2, 3, 4, whatever the positive value, it will be giving you the time complexity order of magnitude n upon k, right? Okay, let's try to execute this. Let's try to execute this. I have taken one simple C code. Let's try to execute. Let's say int n is the variable, print f, enter the number, enter the value of n, scanf. Try to execute how many times this statement will execute. Let's try to code this. How many times this n will end. Print. Let's see. While as what was the condition is, while let's say n is greater than let's say n is greater than 1. If I'll say n is greater than equals to 1, let's say n is greater than equals to 1, this is a condition. Sorry, yeah. What was the condition? N is equals to n minus 1. So by the analysis that I told you, it should execute for n times if n is equals to n minus 1, right? Let's see. Enter the value of n is, let's say, 5, and to just show it, I have to print something. Let's say I'm printing hello backslash. Okay, I'm printing hello. Now let's see how many times this hello will print. For n is equals to 5, it will print 5 times. And for if there is n is equals to 2, how many times it will print? How many times it will print? 3 times. Let's say here you have n is equals to let's say 5, n is equals to n minus 5. How many times it will print? It will print for 1 time only. So this is how the code will work when you are executing any program for n is equals to n minus 1. Now let's see for some other statements. If you have while n is greater than 0, if the statement something like this, n is equals to n upon 2, how many times this will execute? Let's check. Let's check for this. If you have n is equals to 1024, let's say n value is equals to 1024 initially, what will happen is, once you will check 1024 is greater than 0, condition is true, you will do what? N is equals to n by 2, means you will do 512. 1024 by 2 is 512. Again 512 is greater than 0, what you will do is you will just divide it by 2 again, 256. 256 also greater than 0, you will divide it 128. 128 is also greater than 0, you will divide it again, it will be 64. Again it is greater than 0, you will divide again. Again it is greater than 0, you will divide again. Again it is greater than 0, you will divide again. Again it is greater than 0, you will divide again. Again it is greater than 0, you will divide by 2. And then you will become at 1. At 1 you have to stop. This is the condition. You can even write it as 1 is greater than equals to 0 or 1 is greater than 1. N is greater than 1, sorry. So let's see how this is executing, how this is working. Let's see. 1024 can be written as 1024 can be written as n upon 2 to the power 0, 2 to the power 0. Is it fine or not? Can you write n is equals to 1024 as n upon 2 to the power 0? This is what you can write it as n upon 2 to the power 1. This is what you can write n upon 2 to the power 2. This is what you can write n upon 2 to the power 3. Means you can write it as 1024 upon 2 into 2 into 2. It will be 128. You can see it is 512. It is 256. It is 128. This is what I am trying to explain you. Now this you can written as n upon 2 to the power 4, n upon 2 to the power 5, n upon 2 to the power 6, n upon 2 to the power 7, n upon 2 to the power 8. How many times you will do it? How many times you will do is, once n upon 2 to the power 10 is equals to 1, you will stop executing. You will stop executing. So for the value of n upon what? N upon 2 to the power with some constant. It can be any constant. This loop will execute how many times? N upon 2 to the power k. Constant is equals to become 1. Now let's evaluate this. You will take this to right side. N up is equals to 2 to the power k. Now if you are having any exponential term in algorithms, just take log. So what you can do is just taking log base 2 on both sides. So what will this be like this? N means you can take log n to the base 2 is equals to, students see, log 2 to the power k base 2, right? Now what log property says? Log property says that if you have log a b to the power c, it will be equivalent to what? C. What c? Log b to the power what? You can even say it as a, something like this, right? So it will become like this, log k dot log 2 base 2. this will come this side, and this will go this, this will be like this only. So it is log n base 2. So now you can see the value of log 2 base 2 is equals to what? So k is equals to what? Log n base 2. This is how many times this loop will execute for n is equals to n by 2. As you have seen that this will execute how many times? N upon 2 to the power 10 for n is equals to 1. N is equals to 1024. So k is the number of times the loop is executing. So k is the number of times. So for example, if n is equals to 1024 students, k is equals to log 1024 base 2. What is this? You can write it as log 2 to the power 10 base 2, which is equals to what? 10. Which is equals to what? 10. So it is executing 1, 2, 3, 4, 5, 6, 7 up to 10 times. This loop for n is equals to n by 2 for n is equals to 1024 is executing how many times, students? 10 times. So this is how you can check. For example, if you have something like this, let's say n is equals to n upon 5. You can now directly write it as k is equals to log n base 5. If you have something like n is equals to n by 3, you can just write k is equals to log n base 3. So this is how it is executing. Now I'll show you with an example also. Now I'll show you with example. Let's see here. Here the same program is, but you have to just check, just change the condition. It is n is greater than 0. Let's say what you are doing is n is n by 2 and you are printing the hello. Let's execute this. Try to execute. Let's say for n is equals to 1024. How many times it should execute? It should execute these number of times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. Right? Let's say for n is equals to n by, let's say 5. Let's say for this 5. It is executing how many times? Let's say 1024. It is executing 5 times. Log of 1024 base log base 5 will be something 4 point something. So it is executing 5 times. Let's say if you are executing it for and again for 2 times, and I'll change the value of n. Let's say I'm taking n is equals to 16. It will execute 5 times. If I will return it as 0, let's see how many equals to 0. How many times it will execute? Let's check again. For 16, it will execute these number of times, right? Same number of times. Let's say if I'll execute it with the greater than 1, how many times it will execute? Let's check. 16, it will execute only 4 times. So if you are writing for greater than 1, it is executing exactly the log 16 base 2. But if you are writing it 0, it will execute 1 time more for that condition. So this is how you can even check how many times your instruction is executing. So this is how you can easily write the code, and whatever the statements you are having, you can just check how many times it is executing. So thank you, students. In the next class, we will be exploring more examples related to this.